Hello. Today we want to explain how to find out how many factors there are of any number, and then we want to explain it using a trick within a trick. The trick, which is readily available on the internet, goes something like this. Let's take 315 as an example. Step 1. Express 315 as a product of primes. I think everyone knows how to do that, and we get 3 times 3 times, we get 3 times 3 times 5 times 7. Now we express the product of primes as exponents. So in our case, it's 3 squared times 5 to the 1 times 7 to the 1. Now take each of the exponents and add 1. Then multiply them all together and you'll get the number of factors. It's quite helpful. That way we make sure that we don't miss one. But why does this trick work? Well, I won't give a full proof, but an example will provide a good explanation. Let's take 63. 63 can be written as 3 times 3 times 7. So we use the 3 and the 7. But notice that we did not use the 5. Now is time for the trick within a trick. What we're going to do is multiply by a well-chosen 1. So since we aren't using 5, we're going to write 3 squared times 1 times 7 to the 1. And can you guess what we're going to do next? Instead of writing 1, we're going to write 3 squared times 5 to the 0 times 7 to the first power. So any factor of 315 can be written as follows, and now that includes 1, so we don't have to remember it separately, as 3 to the something times 5 to the something times 7 to the something. Remember that it's 3 squared times 5 to the 1 times 7 to the 1. So there are 3 ways we can fill out the exponent for the 3, 2 ways to fill out the exponent for the 5, and 2 ways to fill out the exponent for the 7. So that explains why we add 1 to the exponent, because we want to take care of this 0 power case. So that covers off one point. We add 1 to each of the exponents to account for the prime to the power 0 to account for that scenario. Now let's answer the question, why do we multiply them together? To answer that question, let's go to 3 old friends that always come up in the how many questions involving how many. We have a deck of cards, a coin, and 2 dice. How many ways can we combine those together? Well, there's 52 cards, 2 ways for the coin to flip, and 12 ways for the dice. So for each of the 52 cards, we could have to do it again because we could have heads or tails. And then for each of those 104, we could have any one of the 12 numbers, so we simply multiply them together. And that's what we're going to do here. There are 3 ways to have an exponent for 3, 2 ways to have an exponent for 5, and 2 ways to have an exponent for 7. That's how we get our 3 times 2 times 2 equals 12. Let's go a little further. The 5 and the 7 may have any of the following combinations. They may both be 1. Maybe it's 5 times 1, or 1 times 7, or 5 times 7. So there's 4 ways that the exponents for the 5 and the 7 can turn out. So for each of those 4 ways, let's fill out the 0, the 1, and the 2 that can be the exponent for 3. So we plop in our 0, 0, 1, 0, 0, 1, 1, 1 into each of those scenarios. So let's extend our chart, and it looks a little complicated, but it's fairly straightforward. If we look at the first line, we're saying that the exponent of all 3 of them is 0, which is 1 times 1 times 1 equals to 1. Let's look at line 5. That would mean the exponent of 3 is 1, and the other 2 are 0, so 3 times 1 is 3. And let's take a look at line 11. The exponent of 3 is 2, so 3 times 3 is 9. The exponent of 5 is 0. 5 to the 0 is 1. The exponent of 7 is 1. 7 to the 1 is 7. So we have 9 times 1 times 7 equals 63. That gives us our full list of factors for the number 315, but they're not in a very good order. So on the left, we have the list as we just produced on the last picture. Now in the middle, we sorted it, and then to the right here, we have counted it from 1 to 12, showing that we got all 12 of our factors of 315. Wishing you a lot of fun and enjoyment in the days and weeks ahead as you enjoy factoring with confidence that you're never going to miss a factor. Thanks for watching.